We focus on understanding of the essential elements that determine the evolution of a coastal sector. And we divided this topic into two parts. In the first, we described the main factors that explain the changes according to the spatial-temporal scale to which they are analyzed.
And above all,
we explain the central concept coastal sedimentary system or coastal cell. The advance or setback of a stretch of coastline is related with two types of phenomena: variations in sea level and the gain or loss of sediment in that coastal sector. According to the spatial and temporal scale at which the changes in the coast will be more important to look at the position of sea level or coastal sedimentary balance. In macro-scale studies, that is to say, those that focus in hundreds or thousands of kilometers and centuries or millennia, are conditioned mainly by the changes in sea level. On the contrary, in the studies of mesoscale, we talk about decades to centuries, or tens or hundreds of kilometers, which are the ones that most directly affect ordination, and land management will need to focus the effort to understand the sedimentary balance. And to do so, we must minimally understand the concept of coastal sedimentary system, which is the geographic area within which the sediments on the coast interact. This coastal sedimentary system can be understood as an open system which occurs within a defined geographic space. That is where the sediments are moving, and we're going to go to name cell coastal sedimentary cell. The outer limits of this sedimentary cell are on the marine side, the line where the waves no longer move the sediment, and it gets the name of depth of closure. By land, the limit is there where the sediment is out of reach of the waves. The lateral limits are there where longitudinal currents, they can't displace sediments. These limits can be natural, like a cape or submarine canyon, or artificial, like the jetties of a port. In this image we show a large port whose outer dike it reaches a depth of 18 meters, and logically, at that depth the waves can no longer move sediments from the bottom. It is beyond the depth of closure. It has become an artificial limit to new sedimentary cells that will now be to the north and south of this dike that defines one of the limits of the system. To the coastal system always arrives new sediments that can proceed of the rivers flowing into it, or from other sources such as cliffs or coastal dunes that provide sediment when eroded. Or they can also come from fragments of living shells in ecosystems close to the coast that fragment when they die and they become sand.
however,
In most places the main source supply of sand or gravel sediments are the rivers, and it will be during the great floods when produce maximum sediment inputs. The two images in these illustrations show how sediment is being contributed during growth phases, during the overflow phases. Let's say these rivers' avenues. The coastal elements, as well as just as they go in and out of the system after spending a lot of time inside it. The main ways to get out of the system are offshore, dragged by the waves and currents. In moments of great temporary or falling by submarine canyons near the coast, inland. When the sands are retained by stable dunes, when they are buried in urbanized spaces. Or simply when artificially extracted for different uses such as construction or agriculture. And so far this first part of this topic focused on coastal evolution, and thank you for your attention.